Hi friends, in this video I'm going to show you how to perform molecular docking using Autodock tools. So for this, first we need to create a folder, then download protein and ligand molecules, and then preparation of the protein and ligand, and docking process step by step. So for this, initially I have created a folder for pH9. So and downloaded the protein in PDB format from protein data bank, and also have created ligand molecule in mol2 format. And then we have to place those two files in the folder that we have created. Then if you wanted to know how to install these Autodock tools, I have created another video earlier, so you can watch that, how to install Autodock in Windows platform. So when you install this software, so it generally save in Windows C program files, and then Scripps Research Institute, and then Autodock folder, and then the actual version. So in this folder we will be having two files, Autodock 4 and Autogrid 4. So we need to copy these two files and paste it in the folder that we have created on the desktop. This one I have created in the desktop. And coming back to the initial step, so first we need to create. We have downloaded the protein and ligand. We have also created the folder. So we have placed all these four files. Make sure we have these four files. One is protein file downloaded from the PDB, and ligand file that we can create, we can download in various forms, but we need to have it in mol2 format, this one in PDB format. And then these two files that we have copied from some Windows C and this particular address, and paste it here. Then preparation of the protein and ligand. So for this, before that we need to change this directory. So first we will click file, then go to preferences, then set. So it's going to open up this pop-up here like this. Then click here on the folder that we have created and select, copy this address, paste it here in the startup directory. Select this, and or you can remove, or just Control V. I have pasted this here and set. We can close this. Then I'm going to import protein. So file, read molecule, select this protein, open. So this is the step we are currently doing that. So file, read molecule, and select protein, which is in PDB format. Once protein is loaded in this Autodock, it is going to look like this. So I am using middle cursor, left cursor, click button to rotate the molecule. Then click on CL on the molecule and change this by atom type. Then it will change like this. Then edit, delete water. Edit, delete water. So all these red water molecules will be removed. Then edit, add all hydrogens. Edit, hydrogens, add. Then it will open this pop-up. Select all hydrogens, no bonded order, and click OK. Depending on the system performance, it will take some time, or it can be done immediately. Then So before this thing, I have to show you something, because this particular protein has 1 2 3 4 5 chains, but we all these 5 chains are similar, so I'm not going to use all of these chains, so I'm going to remove. So S is for select, so I'm going to select here all the chains except A, so I'm going to use only chain A. So whenever we select this one respectively, it is also selected in the molecule. Yeah. So then we can edit, delete selected atoms. Then it will open up this pop-up. Click continue. Then we only have chain A. Then we need to further filter down. So click on this arrow mark. It will show what are the amino acids present in this chain. So go down completely. So till here, valine 583, these are the amino acids. This IBP is ibuprofen co-crystal molecule, and rest are ions or some kind of another molecules, not water molecules, but some kind of molecules used as adjuvant in crystallization process. So we don't need these molecules, so I'm going to remove these molecules as well. Once you selected all these atoms, click edit, delete selected atoms. So then again it will open up this particular pop-up and click continue. Once this is done, then we will go back to the actual procedure. Then again ligand, input, open, select mol2 format, select the ligand which we have designed or downloaded from the database, click open. Click OK. Then ligand, torsion tree, set number of torsions. Ligand, torsion tree, set number of torsions. It will open this, then dismiss. Then ligand, output, save as PDB-QT format. So this is in PDB-QT format, so you can save it like that, ligand. Then grid, macromolecule, choose, select PDB and select molecule. So it will open up this pop-up, select PDB. So this is a PDB protein molecule we have to choose here, because we are selecting the macromolecule. Select molecule, then save, select molecule. Then it will open up another pop-up. So we are going to save it as PDB-QT format protein. So we have saved ligand as PDB-QT and protein as PDB-QT. So we can also see the number of files increased here. Earlier it was 4 files, now it has 6 files. Then grid box again, select XYZ coordinates. Grid box. So generally we keep it as 60 radius, 60. this one, if you look at here, so the grid box is basically, so we're selecting grid box for the active site. So the active site is generally present at the position of this particular place. So this ibuprofen is located in active site, that is called binding pocket. So I'm going to click that to see where this molecule is. So I'm just zooming a little bit. See, this molecule is this is our molecule, this ligand molecule, but ibuprofen is present somewhere. So to see this one, we can also bold this, and we can change little bit to see. So if we see here, see inside this box there are selected atoms, those are ibuprofen. So but this box is not exactly not in the middle of this ibuprofen. I'm going to put this box a little bit upside, so like this. So we can see here these dots. I'm also moving this box a little bit there. Now it looks like in the middle. If you see these dots, see it looks like it's in the middle. So we are providing then file, close, saving current, then grid, set map types, choose ligand and select ligand. Grid, set map types, choose ligand, then it will open up this, select the ligand, then grid, output, save as GPF format. So I'm going to give number 1 dot GPF, save, then click run auto grid, then it will open up this pop-up. So program file auto grid 4, but it is not, this is just name, it's not address. So we are going to choose address from this. So auto grid 4, see now it become an address bar. Then parameter file, select browse, parameter file is GPF file we have saved as 1, so I'm going to select that. So this is, so it's going to generate log out file as glg file, then click launch. It's going to take around 2 minutes. See, if you see this particular folder, so how many files we have generated, almost like 18 files we have generated. Some are map files, some are so once this is done, that pop-up will disappear. Then we can go to docking, macromolecule and set rigid file name. Docking, macromolecule, set rigid file name. So the rigid file name is protein, so we're going to select protein and click open. Then docking, choose ligand, choose. We'll open up this one, select the ligand, then open up this one, accept. Docking, search parameter, genetic algorithm, okay. Docking, search parameter, select genetic algorithm. It will open up this window and accept. Then docking output file, Lamarckian algorithm, give file name, okay. Docking output file, Lamarckian genetic algorithm. So I'm going to select this one as 2.dpf. Save. So it become 19 files here. Then last step, run. Run Autodock. Then it will open up this pop-up. Select the parameter, path name as Autodock 4. So this is just name. So this is not address bar. Select Autodock 4 from here. Autodock 4. Open. So now it becomes address bar. I can select 2dpf, but it is just name, not the address bar. Select 2dpf. Then click launch. It is going to take around 20 minutes depending on the molecule. So after this 20 minutes, that pop-up will go away. Then click edit, delete, select, delete all molecules. Edit, delete all molecules. And it will open up this window. Click continue. Then click analyze, docking, open. Select this DLG file, click open. Then analyze, confirmations, click load. So it will open up this window. So based on, so this is a double click on the fast energy. Then analyze, macromolecule, open. Analyze, docking, show interactions. So it is going to open up these two windows. So we can change the spacing to 1.0, 0.10. Yeah. And then so we will solid, So you can play around to see different interactions. So the interactions are only this one because this is not a good molecule in terms of that. Or we can also change the graphic view. I can say click by interactions. If any there, they will represent here.